In lesson 3, we're going to learn about how to solve inequalities. Before we can do that, we have to talk a little bit about what inequality symbols mean and a little bit about interval notation and how to graph inequalities. So first thing is looking at these symbols here, what do they actually mean? So the first one means less than. And then the less than symbol with the bar underneath means that something is less than or equal to. So the bar underneath means equal to. And then when we're looking at the other ones, the other symbol means greater than. And then greater than symbol with the bar underneath means greater than or equal to. So greater than or equal to. So then looking at graphs of these, one important thing that you have to know that if we use a less than or equal to or greater than or equal to symbol, we're going to use a closed circle when we're graphing because that means we're including the number that we're getting close to, where if we use strictly less than or strictly greater than, we have to use an open circle because we're not actually including that number. So let's look at some examples. So if we have this example, x is less than 2, what that looks like on a graph, so let me start with the graph and we'll go to interval notation. I would have 2 and then let's just put a number on either side of it. But at the number 2, I would have to have an open circle because I'm not actually including 2. I'm getting really close to 2 but not actually including it. And x is less than 2. So that means x is going to be all of the numbers that are to the left of 2 because it's less than 2. So another way to remember this is if you look at the symbols, as long as x is on the left of the symbol, see how the arrow is pointing to the left? My shading is also going to go to the left. So it's kind of like a trick to kind of help you remember. Interval notation means you're going to use open or square brackets. And if I'm going on forever in one direction, I'm going to be using infinity. So in this case, I'm going on forever in the left, which means negative infinity. So negative infinity. So after I look at the graph, I'm going from negative infinity all the way up till 2. And since I'm not including 2, it's what we're going to call an open bracket or a soft bracket, meaning it's just a round parenthesis bracket. So we can do the same idea for x less than or equal to 2. And let's look at how this changes. So on a number line, so let's first look at that. Let's put some points on here. At the point 2, since I am including 2, it can equal 2, I do a solid circle, and then again, your shading is going to go to the left. When I go to write my bracket, I'm still going to have a round bracket around negative infinity, and that's always going to be the case. Positive and negative infinity are always going to have the round brackets because you can never actually include infinity, you always just approach it. So around 2, though, in this case, I can include 2 this time. So it's going to be a square bracket or a hard bracket. So that's hard brackets or the square brackets always go with filled in circles. Open circles are the open brackets or the soft brackets or the round brackets. Let's look at the same idea, but let's look at it for greater than. So what if we had x greater than or equal to 3? Now let's say negative 3. So x is greater than or equal to negative 3. So let's plot some points. So let's say negative 3, negative 2, and then over here will be negative 4. When you go to shade this, you are going to include negative 3, so it's going to be a solid circle. And x is greater than, so that means we're looking at the right of this. Again, look at that arrow. The arrow is pointing in the direction to the right, which means my shading goes to the right. Keep in mind that this trick only works though if x is on the left hand side of your expression or your equation. So when I look at this in interval notation, you always go from left to right looking at your graph. So it's going to be a square bracket around -3, and then I'm going to positive infinity, which means it's going to be infinity and a round bracket always around infinity. I always like graphing first before I look at interval notation because it kind of helps me go from left to right. You always want to do interval notation from left to right. Let's look at our last scenario here when x is strictly greater than -3. So let's look how things change here. So we're still going to have our number line the same. But when we go to do our circle, it's going to be an open circle. Again, we're looking at all numbers bigger than -3, so we're still going to shade to the right. When I do my interval notation, though, it's going to be 2 round brackets because you're not actually including 3, you're approaching -3. So that's all of your different scenarios for that. Let's actually now go to look at how do we solve inequalities to get these solutions. So there's some different steps. Again, you're always going to use distributive property first. Get rid of those parentheses. If you have fractions or you have decimals, use those tricks that we talked about. Combine any like terms, move things from one side to the other. Whatever you do to one side, make sure you do it to the other. And then you're going to get x by itself by multiplying or dividing. And then we're going to graph the solution set. Okay, so that's something that we're going to do with inequalities. So the first property that you have to know whenever you are looking at inequalities, um, the same rules for addition and subtraction apply, where whatever you add to one side, you just add it to the other. Whatever you subtract from one side, you subtract from the other. It's the same rules as equations. So basically, you kind of ignore the inequality symbol and just treat it like an equation. So when I look at this, I'm just going to subtract 5 from both sides, and I'm going to get x is less than 2. So that's that inequality. That's all you got to do for it. Then you go to graph it. So we have 2. I like to just make sure I get a number on either side of my number line. And x is less than, so that means it's just going to be an open circle. The arrow is pointing to the left. X is less than represents all the numbers smaller than 2, which means I'm shading to the left. If you wanted to write this in interval notation, your solution would be negative infinity to 2 and open bracket. So those are kind of all the different ways you can represent this. Let's look at another example like this. So for this one, we have x minus 6 is less than or equal to -3. So to solve this, bring the 6 over because you got to get x by itself. So we have x is less than or equal to 3. So let's look at this. So there's a solution. Let's look at this on a number line. So we have 3. And for this one, we're going to have a solid circle because it's equal to, it's less than or equal to. My arrow is pointing to the left, or also think of, well, if x is less than or equal to if x is less than or equal to 3, what numbers satisfy that inequality? Well, 2 satisfies that inequality. It's less than 3. 1 does. Anything less than 3, so it's going to be to the left of it. Interval notation, negative infinity to 3, and you can include 3, so it's going to be a hard bracket. All right, let's look at some examples now that involve multiplication and division. So this is where there's a little bit of a difference. So basically, whenever you start with something, so if A is less than B, and I multiply by a positive number, so C is this positive number, the direction of the inequality is staying the same. It's not going to change. But if I multiply by a negative number, notice how the sign changes. And that's always going to be the case. If you start with 3, which is less than 4, and I multiply both sides by -1, I'm going to get -3 and -4 here. But isn't it true that -3 is bigger than -4? It's less negative. So notice how the sign would have to switch in order to make that statement true. So this is a property, and it's just a rule that you need to remember. So this is a really important rule for you to remember. Whenever you are multiplying or dividing an inequality by a negative, you have to flip the sign. So you have to flip the sign whenever you multiply or divide by negative. Multiplying by a negative is the same thing as or dividing by a negative is the same thing as multiplying by a reciprocal, so it's the same rule for both. So if you look at this one here, I have 3a is less than 15. When I divide both sides by 3, I didn't divide it by a negative, so I'm just going to keep the sign exactly the same. A is just going to be less than 5. So when I graph it, this is just like the problem we've done on the previous page. So this is nothing out of the ordinary for this one. Open circle. A is less than 5, so all the numbers smaller than 5 are going to be to the left of it. Interval notation. Negative infinity to positive 5 with a round bracket. So that one is just you divided by a positive, so nothing different happened. But when I divide by a negative, so looking at this next example, I have to divide by a negative 2 in order to get a by itself. So whenever you divide by a negative, you have to flip the sign. So notice that I flipped the sign. This sign here became going the opposite direction. So that's an important thing to remember. Whenever you're dividing by a negative, you have to flip the sign. So my answer is a is greater than or equal to negative 9. So when I go to graph that, we have a solid circle at negative 9, and a is greater than, so I'm going to the right. If you wanted to look at this, an interval notation, negative 9 to positive infinity would be how to represent that. Again, whenever you guys are doing the interval notation, always think of it after you've graphed it on a number line. It's just so much easier to look at it from left to right once you can visually see it on a number line. Alright, let's look at another example of this. So for this one, we have negative x over 4 is greater than 2. I need to get x by itself, so it's a fraction. So if you ever want to get rid of fractions, remember you multiply by the LCM, or whatever number's in the denominator. In this case, I just have a 4 in the denominator. But I need to get rid of this negative as well. So basically, if you multiply both sides by negative 4, it's going to cancel those negatives into a positive, and it's also going to cancel those 4s. So this is going to be x, because these are going to cancel. Negatives cancel as well. Flip the sign because I just multiplied by a negative, and I get negative 8 over on the other side. So again, I flipped the sign because of that negative. So it's not just dividing by a negative, it's also multiplying because they go hand in hand. Flip the sign. And then if you were to graph this, you have negative 8, negative 7, negative 9. You're going to have an open circle, and you're going to be shading to the left. Interval notation, negative infinity to negative 8. Round brackets around both. Alright, a couple more examples of this. So on the next example here, same idea with treating it like an equation and just remembering if you divide or multiply by a negative, you got to flip the sign. So I'm just going to go through and solve this like it were an equation, and then just remember that if I divide or multiply by a negative, I'm going to flip the sign. So first thing we're always going to do is get rid of those parentheses. So you distribute and carry everything else down. Next thing, combine any like terms. So I'm going to have a 2 and a 4 on this side. Let's combine those. And now I'm trying to get x's by themselves. So I'm going to bring the 6x over, trying to avoid negatives. But remember, it doesn't matter which one you choose. Bring the 14 over. So we have 20 less than 10x. Divide everything by 10. So we have 2 less than x. Now, remember, you're not going to be shading this one going to the left because of the sign, because my x is on the right hand side. So if I want to fix this, I would have to keep the sign opening up towards x. Basically what this is saying is 2 is less than x, or x is greater than 2. These are equivalent, but you just have to make sure that whatever way the sign is opening towards, it's opening towards the x. It's got to stay that way. So now when I graph, I know that my shading is going to go the direction of the arrow, which is to the right. But it can only be that way if x is on the left. So it's going to be an open circle at 2, and I'm going to be shading to the right. So all of the numbers bigger than 2 are to the right of 2. Interval notation, open bracket, 2 to infinity. Alright. And that's it for that section. So it's really just like solving equations. Just remember the one rule: if you divide or multiply by a negative, you have to flip the sign.